So in this lesson, we'll be going through finding the derivative using first principles. So whenever they refer to first principles, we need to understand that we're referencing this formula where f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all divided by h. So whenever we're dealing with first principles, this is the formula we'll be referencing and this is the formula we'll be using. So let's attempt the questions that we've been given. Suppose we're given these exam type questions where we're asked to determine the derivative from first principles. First principles meaning that we'll be using this formula for each of the following. So the first question they're asking, giving us that f of x is equal to 1 over 4 is equal to x cubed. So what we need to understand is that f of x in the formula is given as f of x, which means then our f of x is 1 over 4 to the x cubed. So we really need to find what f of x plus h is, and we can find f of x plus h, and we'll do that really by manipulating the formula and substituting x plus h where there's x in the original. Means that we're going to substitute x plus h and we're going to have this equation. So we just need to really simplify this equation by saying x plus h, x plus h, and then we're going to be performing some algebra. This is where algebra gets important. So we're going to FOIL these two brackets, then we're going to get x squared plus 2xh plus x squared, and then we're also going to apply the same thing on these two brackets. Then we're going to have x cubed plus 2x squared h plus xh squared. Then h will multiply the x squared. We have x squared h plus 2x h squared plus h cubed. So really we can go ahead and multiply out the bracket by 1 over 4. We have 1 over 4 x cubed. So you must also pay attention that we have a like terms 2x squared h and 1x squared h. So we can add or subtract those. So 2x squared h plus x squared h, when you add them together, you're going to get 3x squared h. You multiply it by 1 over 4. You're going to have 3 over 4 x squared h. Then we have another pair of like terms of 1x h squared and 2x h squared. When you add them, you're going to get 3x h squared. 3x h squared multiplied by 1 over 2, you're going to have 3, 4 x h squared, and lastly multiply h cubed by 1 over 4, you're going to have 1 over 4 h cubed. So what we just really try to calculate or find is that this is our f of x plus h. So what we just calculated here is our f of x plus h, and remember we already have our f of x over there, so we just need to substitute everything to the formula. We have to substitute everything into this formula, and then we're going to find really the derivative. So we can go ahead and do that. So which will be seemingly easy because we have all the resources we need to answer the question now. So we're going to go ahead and say f prime of x is equal to limit as h approaches 0. We know that f of x plus h, we're going to substitute 1 over 4 x cubed plus 3 over 4 x squared h plus 3 over 4 x h squared plus 1 over 4 h cubed minus minusing our f of x, which is 1 over 4 x cubed, and this is all divided by h. Then if you look closely, you see that negative a quarter x cubed and quarter x cubed cancel. Then what we're left with, we have a common factor of h from these three. Therefore, I'll say limit h approaches 0. Take out h as a common factor, we'll be left with 3 over 4 x squared plus 3 over 4 x h plus 1 over 4 h squared divided by h. Therefore, the h and the h will cancel, and as you can see, this is becoming and looking much more easier. The limit as h approaches 0, we have 3 over 4 x squared plus 3 over 4 xh plus 1 over 4 squared. We go ahead and substitute really 0 with this h. We have 3 over 4 x squared plus 3 over 4 x, substitute 0, 1 over 4 0 squared. Then our final answer will be 3 over 4 x squared, and that will be the answer, and get all our marks. So another trick you can use really to confirm if the answer is correct is to just take the original f of x, which is 1 over 4 cubed, and find the derivative using rules of differentiation, which will be, we drop the exponent, we subtract 1 from the exponent, which will be 3 over 4 x squared. We're only using this as a method of checking our answer only. So we're checking if our answer correlates with what we calculated and really is correct. So it means that we guaranteed to get all the marks. So it's always a trick that's used to use. Don't calculate. When they ask you for first principles, don't use rules of differentiation. Always, as they say, first principles. Always use this formula for calculating the derivative using first principles. So let's move on to the next question, which is question number 2. So in question number 2, they're giving us that now we have f of x is equal to something different now. F of x is equal to 1 over x, meaning that now our new f of x is 1 over x. Now we need to find what our f of x plus h will be. Our f of x plus h will be 1 over x plus h. So that's our new f of x plus h. Now what we do, we just substitute everything into a formula, and we'll have f prime of x, limit is h approaching 0, f of x plus h is 1 over x plus h minus our f of x is 1 over x, and then divide everything by h. So really my advice when it comes to this step is really take some time, really isolate this here and work on it on the side, because it can get very long, a bit confusing. So let's try and really simplify this fraction. So the LCD will be x plus h, and then have x minus x plus h, which will be x minus h divided by x plus h, which will be equals to x's will cancel, then you'll be left with negative h over x squared plus xh. Now we can substitute it back into our working, which will be limit as h approaches 0, we're substituting back, minus h over x squared plus xh, so divided by h over 1, and our limit approaching 0 will be h over x squared plus xh times 1 over h, which means our h values will cancel. Then we'll be left with and bring our working here. We'll be left with limit h approaching 0, 1 over negative 1 over x squared xh, and then we can substitute 0 with this h, and we have x squared plus x times 0. Therefore, final answer will be negative 1 over x squared, and then we're going to get our full marks. As I said before, you can take the original function, write it, eliminate the fraction, rules of differentiation, drop the exponent, subtract 1 from the exponent, and your final answer should be negative 1 squared, which really corroborates the same with the answer we got. So that's really the schematic of first principles. So let's move on to something